Good day, students. This is the final session on a series of lessons on hybridization in carbon bonding. We discussed sp3 hybridization. We also discussed sp2 hybridization. Today, we are going to look at sp hybridization, just to analyze the sequence of events that will happen here, and then we should be in a position now to look at why we are calling it sp hybridization. Last lesson we discussed sp2 hybridization, and we ended up by concluding that all our alkenes will show us sp2 hybridization. So just analyze again the ground state electronic configuration of carbon, and also the excited state, the electronic configuration of carbon. It's very important for you to be in a position to tell the difference between the two. So we want to look at an example of a molecule such as ethine. Okay, the formula for ethine, we can say our ethine is C2H2. Okay, this molecule is called ethine. Okay, it's an alkyne, just from the name ethine. Okay, right. So we are going to analyze what is happening at each. So as before, we are going to look at two carbon atoms. What is happening on this carbon atom is also what is going to be happening on the other carbon atom. Okay, right. So let's say we are going to have this carbon atom bonding with that carbon atom. Okay, so we form a bond here. So we have an overlap of the orbital of this carbon atom and on that carbon atom. Okay, so we have an orbital of the 2s. Okay, the 2s orbital, and then that will give us a sigma bond. Okay, and then we are talking of a hydrogen, one hydrogen coming on that carbon. So this is one hydrogen coming on that carbon. Okay, so what is happening here is also what is happening on that. So that can also be a sigma bond. Okay, right. So do you see what is happening now on each carbon atom? Okay, we are going to have this electron. It's not going to participate in bonding, and also that electron is not going to participate in bonding. Okay, so we now have, okay, two electrons from the 2p not involved in bonding at all. Okay, just to take you back, when we discussed alkenes, we only had one electron not involved in bonding on each carbon atom. Now we have two electrons not involved in carbon bonding, so in bonding. So what we can do here is we can draw it like that. Okay, let's just draw it like that. Hopefully you'll be in a position to see the diagram. Okay, let's just say this is the first electron, this one. I will draw it slanted so that we can actually see what is happening. So we have that. Okay, let's say that's that one. Okay, not participating in bonding at all. All right, so let me also draw the other one. I'm just drawing them slanted so that you can actually see what is happening. So this is the second one. Okay, right, so this is the second one. One electron not involved in bonding. Okay, right? So what is your prediction here? What's going to happen? All right, previously we said these ones will overlap sideways. That's the first sideways overlap. Okay, and again, as you predicted, there is also going to be another overlap. Okay, so we are actually going to have two sideways overlap. Why? Because we have two p electrons that are not participating in bonding. All right, so what will be the picture like at the end of the day? We are going to have, okay, our molecule like this. Okay, so I can draw it like that, and then I draw it like that. Okay, like this, like that. So that's pi bond 2. So this is the first pi bond, the first one. All right, I can call it number 1, overlap number 1, overlap number 2, overlap number 1, overlap number 2, because they overlap above the plane and below the plane. So this one is pi bond 1 and this one is pi bond 2. Okay, remembering that this is still sigma bond from previously. Okay, so all in all, we have one sigma bond and two pi okay, bond. Okay, this is what we are seeing here. So at the end of the day, when we are illustrating this molecule, one sigma bond, a pi, and a pi, and we have our triple bond. Okay, so at the end of the day, in a triple bond, we have sigma bond, a pi, and a pi. And this bond is very, very strong. Okay, so at the end of the day, what are we saying? Alkynes, okay, alkynes also show what type of hybridization. I only used one S, okay? Alkynes. I used one electron from the S, but I only used one electron from the P, as you can see here. These two electrons were not involved in bonding. So, one electron from the 1s, one electron from the P orbital, and as a result, we say alkynes show sp, hybridization. Sorry for that. Hybridization. Okay. All right. So we have analyzed that there are types of hybridization that we can actually see here.